it says that I would be live actually. So normally it should. Ah, yeah, now it's 10 seconds. Okay, so maybe it was just to reload the website. Okay, so then we go back to here. So maybe Nicolas, you come also to the stage. Yeah, so maybe I start. So I already said a very warm welcome from my side, and I'm very happy to have you here because it really makes a difference. And I'm also too happy to have everybody on the Zoom and in the live stream because, as Guillaume said, it's always a lot of work, and therefore it's also a lot of fun to see when things work out. So maybe I start. So I already said a very warm welcome from my side. Maybe again, could you put it to because it really makes a difference. And I'm also too happy to have everybody. Could you put my computer to mute? Live stream here, because thanks. Good. Yeah, because it's a lot of fun for me always to see when students have fun with the things that we prepared, and yeah, therefore a warm welcome from my side, and I will also continue and we'll have a lot of chances to discuss during the week. So then I hand over to Nicolas for giving his welcome words.
Yes, thank you, Marc-Oliver. My name is Nicolas Montavont. I'm a professor here at IMT Atlantic, and I'm very happy to see you here. I hope you will enjoy the week. What I especially like in this school is that we have two kinds of sessions. One is the keynote, but we try to make them not too long, so you don't fall asleep. And then we have some hands-on to practice a bit, because IoT is about practicing and seeing the real things. This year we start the big challenges, the project that we will present this afternoon on Wednesday only. So you will have 3 days working on the challenges, and I hope that you will learn things and you will find this cool. Yeah, that's all I wanted to say. Welcome.
Very good, and then yeah, you can also clap your hands. Yes. And then we also have Sebastian, who is connected with us, and Erkin will put him to the screen.
Yes.
So hello, Sebastian. It's a pleasure. As we don't see you yet, but if Erkin puts you full screen, you have to pin him.
Yeah.
Okay. And it's a pity that you cannot be here, but the series typically is alternating between Germany and France, and so next year we're already starting to discuss a little bit with Fabian that we will go again into to Germany probably, and therefore you will have the chance to see Sebastian in person for those participating next year almost certainly. So Sebastian, you're on the screen and the floor is yours.
Good morning, everybody. Sorry for maybe not being perfectly synced. We had some minor audio issues for me to hear what you were saying in the lecture theater, but a warm welcome from my side. It's a great event. I had the pleasure in 2019 to also attend this event in Munich, and I think you are part of an exciting activity that I would like to thank Marc-Oliver very much for doing this so passionate and putting so much effort in organizing such a great event. I'm sure you will have great fun. And from my side, I wish you a great event, and hope that you take a lot of exciting experiences home with you, and that you also learn new things and meet new people. So enjoy, and I wish you the best possible event under these difficult circumstances, but I'm sure Marc-Oliver and his team did everything to give you the best possible experience. So enjoy. All the best from my side.
Thank you very much, Sebastian, and it's the pleasure is also all mine to have you on board, because it's always a pleasure to work together and do things together, and I'm sure we'll continue doing that. Yeah, so thanks a lot. All right. So now I put a little bit some statistics, and so overall we have 124 people that are registered for the event. We have 18 people on site. We have 9 people via Zoom. We have 76 that are registered for the live stream. Maybe there will be even some more or some less, so we'll see. And therefore also it's good when you share with your friends, because the more people we have, the more interesting, of course. We have 12 staff, and we have 8 keynote speakers. We have 8 keynotes. We have one so-called fireside talk, which will be upstairs on Thursday. We have 2 hands-on sessions, one today by Josephine and one tomorrow by Siemens. We have 4+ challenges that, as Nicolas said, you will start working on Wednesday. We have one social event, which will be tomorrow evening. We have 2 common dinners, today and tomorrow. We'll have a hack night with pizza on Thursday. And we have one beautiful city that we are in that you should also not miss. This is the distribution of applications, just for info. This was just also interesting, dietary restrictions. These were the t-shirt colors. Then now it becomes more topic related. So this is your experience regarding the IoT. On the right side you have more experience, so most people have medium experience in there. Then IoT security, people are a little bit less experienced. Regarding programming, you have quite good experience, which is good, because we'll be programming some things together, especially on today and tomorrow, and on all days actually. Regarding machine learning, which might also be interesting in some challenges, you're not so experienced. And yeah, so this was it for the statistics. And now I go to the program. If you don't have it yet, we printed it out enough times, so it's laying at the entrance, so you can also get a program there. So I'll make it a little bit quicker, as we are a little bit behind the time. So yeah, I will also introduce the elements once we come there. This will be the program tomorrow. Or let's maybe put it here. So I will do the intro, and then afterwards Josephine will, and then you will do your posters, and then Josephine will do the Celonis data analytics challenges. And then tonight we have the dinner. Tomorrow is the Siemens day, so we have 2 keynotes by Siemens, and we have a nice cybersecurity hands-on challenge with nice prizes if the luggage of Fabian is arriving in time. In the evening we have the social event and also a dinner. On Wednesday we have AWS, so we go a little bit into cloud and security there. And we go into virtual reality and digital twins in the afternoon, maybe even with some hands-on. And then you start working on your challenges. Evening at your own disposal, so you can continue with your challenge, or you visit the city. So you could make it dependent on the weather a little bit. Then on Thursday we have the open vehicle day with some open source keynote, which is also very interesting, between prototyping and market-ready products, and a fireside talk. And then you'll be working on your challenges. On Friday we have a keynote by Airbus on cybersecurity, and then you will be presenting your challenges, your results of the challenges to the jury. And then in the afternoon we'll also have the winner coronation ceremony, where you will get some prizes for the winning team. And then we end around 3 o'clock. Do you have questions? Everything is clear? Good. Yeah, then we come to the first keynote, and yeah. So as said, we have the Slido, where you can, thanks a lot, Guillaume, and see you. So we have the Slido. So everybody who has a question, please put them either to the Slido, or if you're in the room, just keep them in mind, and then you can ask them after the presentation. So,
Yes, so let me introduce formally our speaker now. So our speaker is Marc-Oliver Pahl. He joined us at EMT Atlantic a few years ago as a professor at EMT Atlantic, and as the head of the chair cybersecurity for critical network infrastructures. He's also an adjunct professor at Carleton University in Canada, and he is the head of the Smart Space research team at the chair of network architecture and services at Technical University in Munich. Marc-Oliver is also very involved in teaching, and he is one of the pioneers of e-learning methods, and he's also the chair of the group at IMT working on the e-learning things. So Marc-Oliver?
Thank you very much, Nicolas.
Working on the e-learning things. So Marc-Oliver?
Thank you very much, Nicolas. IoT meets cyber and security. Through software you can reconfigure IoT things that are connected, so software is actually ruling your environment. Connected software programs are controlling, monitoring many entities around you. This brings a lot of opportunities but also lots of challenges. In my keynote I will set the stage for IoT meets cyber and security. That makes it difficult for me to create the air pressure to speak. And when I do this, it's relaxing a little bit, and then it's easier for me to speak, and I also have more volume in the voice. But yeah. Okay. So as I said in the trailer, so this is the keynote where I want to set a little bit the stage. So this is the abstract that you might have read or not. So title is IoT meets cyber and security, and topics are Internet of Things, obviously, that are connecting a lot of things. Programming, it brings opportunities, it also brings challenges. I will introduce a little bit to that. Software drives infrastructures that we have, and yeah, therefore it's important to look at software, the role of software, and the need for security in there. Okay. So, you could ask yourself, what is the Internet of Things? You could also ask yourself, where is the Internet of Things? Who has contact with the Internet of Things? By that I mean when you walk around in the street, or when you think about your daily life from morning to night, when do you have contact with the Internet of Things? And then you could think about, where do I find software around me? Then you can also think, where do I not find software around me? Then you can think about, what are advantages of software control compared to hardware control? And then you can think about what are risks of software control compared to hardware control, so plus and minus. And then you can think, how does cybersecurity help, or how does it work? And these are some of the questions we look at together now in the next minutes. And the first part I titled From Hardware to Software Control. And this is a good example of, can you turn on the sound?
What?
Can you turn on my sound?
Ah, yes.
Thanks. Good. This is a good example of hardware control. I'll tell you in a second why. So there you have these physical pins here, and they are the hardware control, so they are the program that is then running here on the part that is creating the music. But you could as well think of that it's a washing machine that has such a control, and it actually had, or any other device where you needed to switch on and off things based on time. So typically you had something that was rotating, and on that there were some pins, and they were matching with some switches, and when they matched, something was turned on or off. Things changed, and we went from hardware to software.
And voila, it's making the music. And if we open it, that is inside. It has a small circuit.
And so here now we have, of course, hardware that is doing something, but on that you have software stored that is telling this loudspeaker what to speak or what to produce. And this is a huge change, because you, if you want to change the melody and you have the equipment, you can just reflash it and then it's saying your voice or something else. So you already see that you have a lot more flexibility with that. Okay, so what is the difference between the two? So hardware might be robust, but it's typically fixed in the sense that you cannot easily change it, because if you would want to change the melody on the other one, you have to resolder the pins. And to produce it, you need tools and your hands. Okay. On the opposite side, if we look at software, you can ask yourself if it's robust. Good thing is it's dynamically changeable, and what you need is a programming device like your smartphone and your head. Okay, so these are fundamental differences. So now next part is about how did we get smartphones? How did computing evolve a little bit over time? And on this slide, you see the first commercially used computers in the 1960s. So they were typically in basements, operated by not so many people. Then we had evolution, we had the personal computer. Then from that, we developed a lot towards more personal devices like iPads or like mobile phones or tablets. And then we had from single user to multi-user. And finally we have ambient devices. So I would say we're not quite there yet, but the technology is there, so the possibilities are there. And from computing paradigms on top, you see that we have mainframes, we have personal computers, we have mobile computing, we have pervasive computing, and we have ubiquitous computing. More about what that means in a second, but it's just good to know the terms. And we'll also see a lot of that during the week. These are just the multiplicities. So you have many people using one machine, one person having multiple devices, And in this last setting, you would have, or you have multiple people using multiple devices. Like your ticket thing or an information screen is in the last category. Okay, so here is just some iconic development of software-controlled devices.
I'd like to see you while I'm working on it. So before I can do that, I have to set up my display in a certain way. Set it up so I see it over like that. That leaves a corner up there, and I say, now computer, do the automatic switching that will bring in a camera picture from the camera mounted on his console, such as the camera mounted on mine is. Hi, Bill. That's great. Now we're connected audio. You can see my work. You can point at it, and I can see your face, and we can talk. So let's do some collaborating.
So I show you these videos for two reasons. First of all, because you're related to computer science, and therefore you should know your history. And second, because it very well shows the switch between hardware and software. So in here we have hardware, because this is a hardware video overlay mixer. And so this guy is overlaid via a physical cable that is there, and that is then getting mixed here to some collaborative software in the background. What is interesting is that this was already in 1967. Then we continue. This is
by trying different sizes of things, we realized it should be really thin, should be light, it would have a stylus for drawing on it, wireless network, flat screen display, keyboard, and all that stuff. So this is kind of the thing I used to hold up back then of what computers should be like.
Okay, and so this is interesting because, again, it's quite a while ago, and it looks a little bit like a tablet. The guys that you've seen before, that was Douglas Engelbart, one of the pioneers of different technologies. They pioneered the mouse and other things. Alan Kay, also a big name. And so this one was already back in 1972.
Here's what I've drawn for the animated section. It's an M-pad, a base station, and a workstation. See anything you want to add to that?
Well, we could add a second pad to show that there isn't a one-to-one correspondence between pads and base stations. I know. We could put it on a tether.
Yeah, I think that might work.
What are you guys working on?
It's the animation section of the M-pad video. Can you think of anything we might need to add to what we've got here?
Well, perhaps we can add a base station here and a radio. To show that the M-pad can roam between base stations.
Definitely. Seamless, uninterrupted communication is an important issue.
How's it going?
Oh, hi, Ron. Well, we've added an M-pad tethered to the first base station, and we've added a second base station to animate roving. You see anything you might want to add?
Well, that looks pretty good, actually. But I know Bob had a few ideas. He's still busy hacking away for the demo, but we should be able to reach him. Bob, this is Ron. Are you around?
Hi, Ron. What's up?
Hey, we're working on the M-pad animation right now. It's all up on WB. Is there anything else you wanted to add to it?
Let me see. Let me take a look. How about adding a second pad out here, maybe at a remote location, and it could show off the audio features of the pad.
Okay, nice.
And this is Xerox PARC, where they also invented a lot of things, where also Apple got lots of ideas. And this was already back in 88. And the good thing there is that everything that they were showing is a real prototype. And they also had, for instance, light-based communication. So the first wireless communication was based on infrared diodes. You might have heard that this is today light is also used for side channel attacks and so on. All right, so this is a little bit the history, and now when we look at how this evolved, so when did it come from research to reality? So in 2003 we had Skype, which is somehow matching with the experience that they created here. In 2008, we had the iPhone as the first real touch-based device that was working properly, and so this related to this development here. In 2010, we had the iPad. And yeah, so these are now some more recent examples for some building automation, which brings us to the question, where do you get in touch with the Internet of Things?
The entire house works via home automation. Every electrical appliance or apparatus you have in your home is controlled by one easy-to-use system. It's all about living more efficiently and at the same time being a bit more environmentally friendly. The entire house of tomorrow is equipped with the most high-tech and coolest gadgets around. I mean, a lot of them aren't even out in the shops yet. In this house, you can control everything by touchscreen. You literally have everything at your fingertips. Now that's what I call easy living.
Okay, and this is something where you probably have access, even though you might not have installed it fully fledged at your home, but this is technology that is ready, that you can easily install and that you can even build yourself.
This is the automation system that I'm running in my house right now, and I want to go through and just give a quick explanation of what these things do and how they work. So we're going to go ahead and start in the first box here, and get this guy opened up. Open all these guys up. First thing we're going to do is we're going to turn those lights back on.
So this guy was building it himself, and this was already back in 2012, so it's even easier to do that today. All right. So yeah, some sources. So we'll share the slides with you afterwards. Okay, so I said building things yourself, so especially on Thursday we also have a lot of open source input, which I like a lot, and so there's this community of open source software, which is there for a long time. And there's also a community of open source hardware, and this was at least co-founded and pushed by the development around the Arduino, because this was the first time where it really entered a bigger market where the access to such technology was possible for a broader market, a broader range of people. Because before, to prototype things, there was no 3D printing for normal people and so on. It was very difficult. And from that time on, this was a spark where really a movement of possibilities of creating open things and creating things yourself started. And this is also historically interesting and important. Raspberry Pi also in that direction. And so one demo we did, for instance, is that we just connected some hardware to do some fancy stuff, that we used our ID cards at TOOM to reconfigure the building, and this was quite easy to do. And years before that, it was super difficult, and you would have gained millions of euros for a research project to implement such stuff. And what is interesting in such a thing is that you have software and hardware, and you have a strong interplay between the two. And when you reprogram the software, the functionality can be entirely changed. Okay, yeah, and here you see a little bit of the setting where we hacked ourselves a bit into the physical space that was there. The good thing is it's not very expensive. Because you get these things for very cheap, and this is good because that means you really have access to such products in order to create, to make, and to be creative. Okay, so this is one of the creators of Arduino, and I will just show you a little bit what he has to say.
So a few weeks ago, a friend of mine gave this toy car to his 8-year-old son, but instead of going into a store and buy one, like we do normally, he went to this website and he downloaded a file and then he printed it on this printer. So this idea that you can manufacture objects digitally using these machines is something that The Economist magazine defined as the third industrial revolution. Actually, I argue that there is another revolution going on, and it's the one that has to do with open source hardware and the makers movement. Because the printer that my friend used to print a toy is actually open source. So you go to the same website, and you can download all the files that you need in order to make that printer, this Arduino board. So the motherboard that sort of powers this printer is a project I've been working on for the past 7 years. It's an open source project. I work with these friends of mine that I have here. So the 5 of us, 2 Americans, 2 Italians, and a Spaniard. So we came together in this design institute called the Interaction Design Institute, REA, which was teaching interaction design, this idea that you can take design from the simple shape of an object and you can move it forward to design the way you interact with things. We worked on Arduino and a lot of other projects there to create platforms that would be simple for our students to use, so that our students could just build things that worked, but they don't have 5 years to become an electronics engineer. We have 1 month. So how do I make something that even a kid can use? So one of the features that I think it's important about our work is that our hardware, on top of being made with love in Italy, as you can see from the sort of back of the circuit, is that it's open. So we publish all the design files for the circuit online. So you can download it, and you can actually use it to make something or to modify, to learn. DIY community that believes in open source, in collaboration, collaborates online, collaborates in different spaces. There is this magazine called Make that sort of gathered all these people and sort of put them together as a community. And you see like very technical project explained in a very simple language, beautifully typeset. Or you have websites like this one, like Instructables, where people actually teach each other about anything.
You told me earlier today that you had no idea, of course, that it would take off like this.
No.
I mean, how must you feel when you read this stuff and you see what you've unlocked?
Well, you know, it's the work of a lot of people. So we, as a community, are enabling people to make great stuff, and I just feel overwhelmed. It's just, it's difficult to describe this. Every morning, I wake up and I look at all the stuff that Google Alerts sends me, and it's just amazing. It's just going into every field that you can imagine.
Yeah, and I think you hear the excitement, and it. I think you all, or most of you, are quite young, and therefore it was not the time where you witnessed this, but it was really a game changer back then. Okay, so this now from hardware to software, and the next part is computing in everything.
Guten Morgen. Allegra. Willkommen im Bündnerland. Ja, guten Tag, schöne Frau. Guten Morgen. Morgen, Bro. Hallo. Hey, Allegra. Ist kurz Zeit? Ja, du. Hallo.
All right, and so this is the last category that I showed before, these screens that are existing, and even though it was used for advertisement, it will be interesting to see when such an interaction possibility is. So there's also a recent art installation in, I think it was in Lithuania and Estonia or something like that, where there are 2 portals, and then you could connect between 2 city center places. And this will be very interesting when this will be coming more. Okay, so what is this ubiquitous computing? So again, just to have a little bit background about the terminology. So you have distributed systems back in the 80s. Then the next thing that came was mobile computing. So this meant you had access to computer resources, and especially to remote computer resources like the cloud everywhere. Then pervasive computing, meaning you have computing in everything. And when you have the 2, then this is called ubiquitous computing. From a device perspective, this means that you have a computer. This is also what we've seen before with the areas of computing. And then you add networking support. That means you have a distributed system. Then you add mobility support. Then you have a mobile system. Then you add pervasiveness support. That means you have a cyber-physical system, so something that interacts with the physical environment. Then you have a pervasive system or a smart device. And then you add software, and then you have pervasive computing, and in order to facilitate software, you typically have middleware that offers you a unified programming interface. Okay. So when we now go towards this ubiquity of computing, we have also 3 flavors of that. So we have VR, we'll hear something about that on Wednesday. Then we'll have augmented reality, which are these devices. So you are still in the physical space, but you have additional info, while in the first you have glasses, and with the glasses you enter into the computer universe. In the second one, the computer enters in your universe. And the third one is pervasive computing, and there you see nothing. And that's interesting because it shows that the technology awareness is decreasing. So in this space, you don't know what is installed or what is interacting with you. And at the same time, the immersiveness, so how the technology is affecting you, is increasing. And this is interesting. Okay, yeah, because you just don't see it. And it's interesting because it has lots of implications, also ethical implications. Do I want to be surveyed? Security implications. Do I want to have my data taken? Do I want to share something? And so on. I'll come to that at the end. Okay, so with great power comes great responsibility.
Now get up.
He is the one.
Show you that because we're in a movie theater and I want to show a movie now, because you see here the metaphor for something that is controlled by software. So you have algorithms, and through the interfaces to you, which in that movie is a plug into your head, but you could also imagine that you have just a space that is transforming, which is a little bit less intrusive. You have a reality that is changeable by software. And this is very interesting, because this is the part where I wanted to show you what the power perspective is. So as someone working on software and creating the hardware that interfaces between software and the physical space, it brings you into a very powerful position. And that also brings a lot of responsibility. On this slide, I want to show you a little bit what are the domains that I'm talking about. This goes now to this question: where am I in contact with IoT systems? Am I aware of that? Is it good? Is it bad? So when we talk about so-called critical infrastructures, what is that? And so here I just put you some examples. So you have healthcare, so you have everything in hospitals, and related to that, you have water supply, you have energy supply, you have communication, you have compute resources, you have production, you have traffic, you have defense, you have banking, you have research and education, you have agriculture, and you have many more. And when you think about it now, as I put them here, they all have to do with software and hardware that is controlled by software. Because even when you buy an Apple, you have logistic chains that are using GPS, where goods are tracked. the one who's fertilizing the things is probably considering stuff from the internet that comes through different channels. So I would say it's inevitable today, almost anywhere on Earth, not to be in contact with algorithms that do something for things we interact with on a daily basis.
Something as simple and innocuous as this becomes a challenge for all of us to maintain accountability and control of our critical infrastructure systems. This actually contains the Stuxnet virus. It's impacting industrial control. If you get up in the morning and turn off your alarm and make coffee,
power plants, power grids,
and pump gas,
transportation, telecommunication,
and use the ATM, you've touched industrial control systems. It's what powers our lives.
This is now the part where it becomes to responsibility or problems. So the good thing of software is that you can reprogram it. So you can repurpose systems easily by just changing the program on them. The bad thing is that you can change software, so you can repurpose things basically everywhere, and that means if someone has access to this software, she or he can reprogram it. And I didn't put the video, but I showed it last year. When you have a robot arm that is connected to a chainsaw in a production site, wherever one would do that, and you approach it and someone changed the code and it's suddenly starting to sue you, it's not such a good idea. And therefore it's super important to take care of the sanity of the processes and of the software development, deployment, and so on. And we even have one in the audience who's working exactly on that in his PhD, so you're just doing that. And cybersecurity for me is really something broad, and it starts from code quality and goes up to access control, to entities, identification, and so on. And the Stuxnet virus was a good example, because there they managed to inject software changes to a system that was even isolated from the internet. So it was not connected, and still they managed to do so. And therefore it's super important to take care of it. And even though cybersecurity risks are a big advantage of cybersecurity attacks is that it forces us to improve the quality of code, to think about how we design our systems and to make them more robust. And this is good. So when you want to structure cybersecurity, you have different ways. At the chair, I currently structure it into 4 axes. I just want to show you so that you have an idea in which directions you can think. So the first one is prevent. So this is security by design. So how can I secure the static part of a system the most possible? But systems are not only static, but they're dynamic because they interact with other systems, they interact with humans. Therefore, you have to monitor the systems, detect anomalies to find out that something strange is happening. When you find it out, then you should do something against. There, it's often good to do it automated, because when you have a ransomware attack, for instance, every second or even millisecond is counting, and you should take care of reacting fast. But in any case, security is nothing that is fully automatable. There's always a human who has to put input so that you can set up the systems, you can understand what's happening. And especially the last part is super interesting. I mean, they're all super interesting, but the last part I find it especially interesting because it's super challenging. Because the systems you secure, they are super complex, and to understand them and to make the link then to the humans, this is something super complex. And on Wednesday, we'll hear a little bit about virtual reality interfaces, which is also something we're working on. And there you then also have different questions, like ethical algorithms. How ethical are the algorithms that you implement? Are they, for instance, biased when they use machine learning, and so on? You can use distributed ledgers, digital twins, so these are some of the technologies that we use. quantum computing is also something that will be a game changer. So we're also doing research in that direction with a joint lab that we're currently creating. So there's also something interesting to monitor in the upcoming years. Okay, and so thank you, summary. I have 2 more videos. So we have seen IoT. These are cyber-physical systems that affect everybody everywhere. And we have seen software control. Gives us a lot of power, but at the same time it's also a risk. So it's an enabler of new functionality, but it also has cybersecurity risks. And it has, it can have errors, can have consequences for humans, which is something that was not the case when we were still with the mainframes. At least not physically directly, because you didn't have a chainsaw that was software controlled attached to your computer. Of a self-driving car and a bike driver here at the bottom. And again, it's software that is controlling it. And it's big data that is getting collected there. So probably Guillaume will tell us a little bit something about big data and how to use it, and also Josephine will look at that. And the second example is this one.
Und Abgleich und eher in Sekundenbruchteilen dann noch Touren gemacht, ja, gehört zur Testgruppe oder nicht.
And there you have profiling, so you have cameras that are surveying the space and that are identifying people. And this is also something where you have, when you create this software, you have big responsibility because you're intruding the privacy of people. Because you don't want to have your profile on the internet that everybody knows where you are at which time and so on. All right, so yeah, so related to my talk, over the week we look at different aspects. So we look at data analytics today, we look at cybersecurity tomorrow, we look at cloud computing and security and digital twins and virtual reality on Wednesday. We look at open source, maker culture, and electric vehicles on Thursday. And on Friday, we'll again look at cybersecurity and also smart connected vehicles. So yeah, thanks for your attention. This was the opening keynote, and I'm looking forward to your questions. Thank you very much. So, do we have questions? Do we have questions in the room? Do we have opinions? Are you agreeing? Do you think I missed some points? Which ones did I miss? Where do you feel yourself affected by such cybersecurity issues? Yes.
I heard what you said about with great powers comes great responsibility, and what you said also with augmented reality. And I was thinking, do we lack here in Europe some kind of ethics, of technology ethics committee? I mean, I think that the guys in California that created the automated software for facial recognition were also the first to pass some laws to prevent it to be used widely as China can be doing. And about augmented reality, I had this idea about the screen of your car. You have some cars that display the road signalization, but what if tomorrow all the cars are equipped with that system, and some commercial purposes want to add ads on your car while you're driving by. Like, you're just driving around a fast food and you have fast food pop-ups while you're driving. And do we lack some kind of technology ethics committee here in Europe?
Yeah, very, very good question, Jonathan. So so I would say what I can tell you is there are lots of ethic committees. So there's like the ACM, IEEE, so the professional organizations that go into that direction. Also, the European Union looks at ethics. At the same time, it's always kind of a reactionist mechanism in the sense that they often see something happening and then the reaction only happens afterwards. And what you say that you have to anticipate, I'm 100% with you. And I would say it would be better to have more. And this is also the reason why I always try to include that in my teaching, so that individually I try to sensibilize a little bit the people towards that direction, because another slide that I also didn't show today is the A-bomb. So it's Oppenheimer who says, okay, if I would have known that this is used as such a weapon, I would never have developed it. And back then and also today, we are in a similar position, because most of you can probably develop self-driving algorithms, profiling algorithms. You can just use the tools and mash them up in the internet. You can also create attack kits and so on. And it's the responsibility of each one of us not to do it. Because even if we have legislation, if we want to do criminal activity, it will not prevent us. Plus, the problem of the internet is also that the countries are connected, and therefore it's very difficult to enforce it. So that means my answer is yes, I would be happy if we have more, but I think it's very difficult to implement.
All right, thank you.
If anybody wants to comment to that, also feel free to. Yeah, thank you for the question.
Thanks for your answer.
Do we have additional questions? Do we have questions from the chat, from the Zoom? Okay. Good. If not, I hope that you took from the talk that with great power comes great responsibility. The IoT is everywhere. All right, then let's continue. And I'll be also around all week, so I'll be happy to discuss further with you in that direction. Plus, you will also see in the PhD presentations that some of you are working in that direction, and I find it a very important and interesting topic. And I also have a student group that is currently working on ethics and autonomic computing, because this is also very nice looking at the two, which is exactly going into the direction of your question. So which ethical rules should we put on autonomous, self-controlled computer programs? Okay, thank you very much. And then let's continue in the program, which is also good, because we are almost in time. Yes.
Can you share the link to the Slido again?
Yes. Yes, so the link to the Slido is sli.do, and then you just have to put FIOT, F-I-O-T, which is the ID. Okay. Perfect. Do you want to connect your computer? Ah, okay. Fine for me. Then I will just open it. This program point now. And do you want to say something to the order? Do we see the order on the slides? Okay, perfect. And so if you're remote, it's no problem. We can seamlessly branch you in. Yes. So, so this is the order. I don't know. Did you do it just alphabetically or?
It's just like.
Okay, perfect. So then, all the people that see their name, please come to the stage. This will be the order of the presentation. And we have how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That means everybody would have up to 5 minutes to present. That means you can be a little bit longer than the announced 3 minutes. I just check if I have a timer for you. But you can already come and queue here. You can, if you love to present behind the podium, feel free to do so. If not, I can give you a microphone. Yeah, and as I said, so the reason why I always put this session is it's good for you to get to know each other, and it's perfect to pitch the PhD as often as possible, because it really forces you to be to the point and to present what you're doing. You have bright minds here to discuss your topics with, and therefore it's a very good chance that you have here, and therefore I'm very happy that you took it. Well, let me just reopen it. Okay, good. So it's quite a while that I didn't use the tool. For the coffee, did we have something? Okay. Yeah, because normally we also have some coffee, so you will hear about it later. So let me just refine what I just created. Good remembrance on exams that I took with this tool. Okay, here it is. Perfect. So you will have this timer, and I will just be there. And then if you want to look to me, then you see how much time you have left. And yeah, so the first one is Baptiste Bouchy. Yeah, okay. So yeah, welcome, and you have 5 minutes, and yeah, warm applause for him, please. To the top.
Okay. Oh.
Good.
So hello everybody, I'm Baptiste Buchy. I work at Femto-ST, the OmniDisk team in Belfort at the UTBM school. So I work on programmable matter. So the idea is to have a huge number of small identical robots who are all connected to each other physically. We maintain at all time the connectivity, so each robot always need to be connected to at least one other. So we have this huge stack, like we can see on the picture on the top right. So we can have like a cube of identical robots, and we want to shift it to another shape. So we have to move each robot by turning around each other to achieve a new shape. So the idea is to be able to take this robot and change its shape anytime we want. Just like 3D printing, when you want to create something, but instead of creating something, we just shift the creation every time we need something new. So there are many things we have to do in order to this to be more practical. First, design these robots, but after we have to, for the software problems, we have to design distributed algorithm, for them to work together. What we want to do to change the shape. Do we want to remove the shape and construct it next to the initial shape? Do you want the robot, to shift around each other, to stay in the same position, but achieve the new shape? So what I did personally is I proposed a new algorithm to change the shape, and we are building a machine learning tool to help us decide what is the best algorithm in order to make the shift, because we have a huge number of robots. So just shifting, just removing or adding a robot can change a lot in the application. It can create a hole. It can prevent us to do some scaffolding. So it's really important to choose the right tool, to choose the right algorithm, because the energy of the robot is really important. Because the robots are so small, there are a lot of issues we find that now are less important in computer science. We have issues about energy, about computational power, about all that. Because the robots are so small, we don't have a lot of these resources. So it can be a really important tool to be able to choose what are the best way to shift the robot from the initial to the final shape. Yeah, I think I finished. Went a little fast, sorry.
Perfect. So yeah, very, very, very interesting. So thank you very much. And just switch to the next one. The next one is Julius Bünger. Julius, warm welcome. Yes. And the stage is yours.
Good morning, everyone. I'm Julius Bünger. I'm from Rennes, from EMT Atlantic. I work with Marc-Oliver, Pahl, and Nicolas. I just started, so I have a topic, but I just looked into it. We go into it. My topic is mostly about classification and managing of secure IoT environments. And that means that has a lot in mind the mindset of, okay, we have devices, sometimes they go out of life. When they go out of life, what do we do with those devices or with parts of them? So we need to have a classification scheme to see what is actually there, what does this device do, what can the components do, how can they be repurposed, or what other purpose can we give to them? So that's the overall big topic. As we just started, we're looking, and it's a very, very big area. We started looking at updating IoT devices or deploying those. So what we currently do is look what's already there, and we see lots of different approaches that focus on different problems of different challenges at different levels, at different focuses. So we can, for example, see that most of the, or one area of publications is looking mostly into the scalability of that. So with the claims of we will have billions, whatever, huge numbers of devices, and they all want to get their updates, some servers might be overwhelmed, the network might be overwhelmed, different things on that level. Then the IoT devices, they have constrained hardware. So they might not be able to, this is mostly interesting when it comes to security. Most of the IoT devices won't be able to run the proper cryptographic means that we can run on our day-to-day computers. So we have to find solutions there. So there are different problems. And there are a lot of different approaches. And as we're currently at the start, we will see where we're going into, and this is the overall picture that we're having now, and I'm very curious where that will go into.
Perfect. Thank you very much. Very good, and I have to know to myself, I always tell the people they only have 3 minutes, because then they perfectly stay within the 5 minutes. Wonderful. Thank you very much also for that very interesting presentation. Let me switch to the next one. It's Ahmed, Shafiq, and Ahmed, warm applause for you. And the stage is yours.
Thank you. Hello, so my name is Ahmed Amin Shafiq. So I am a PhD student working at Femto-IST lab with Omni teams, with some industrial engineering backgrounds. And I'm working on programmable matter. So technically I am at the same lab, at the same team with Baptiste, but here we looked at programmable matter in different approach. So programmable matter is generally defined as a collaboration of system of elements that tends to create and alter between different formation. But here we talk about a new definition of programmable matter. So we thought about what is it possible to find matter that already exists in nature and have some embedded intelligence. So instead of looking of thinking about systems with CPUs and actuators and sensors, is it possible to find matter that have already that embedded? And we have looked out in nature, and we have found that there is things that already exist, and we didn't think of it. So like sunflowers, they have sensors to feel the sun and the actuators to follow it. There is also some metals that expand whenever they heat, so they act like actuators and sensor. And what is most beautiful that they also have memory, so they can store up to 1 or 2 shapes. So generally, I work on materials, and most precisely, I work on designing interfaces for 4D prototyping and actuation. So my research questions are more about the behavior materials. How can I represent this behavior? Is it representable by equations, or can be simulated or represented, or can be controlled precisely, and how to do it? So my thesis is about to answer to all these questions. And what I am now currently I am in need of finding a way to precisely simulate these materials, because the problem here is these materials are meta-materials. So meta-materials that are materials that are highly customizable. So we need either to do physical tests, or to develop our software to do simulations. But we found different solutions that we are working currently on. So until now, we have developed many devices. So we have 2 patents. The first patent is the one that you are seeing now. So this is a membrane. So we have metal that can create bumps, and combining different nodes, we can create 2.5D shapes. So it is just a deformable surface that can serve as a dynamic braille screen, or also for representing geometrical interface dynamically. And we have developed another model that we have changed the structure, and the patent is ongoing. So we hope that we get an answer the following month. So this is what I am currently working on, and I'm very happy to answer your question, or to develop more if you are interested.
Perfect, thank you very much. and as you mentioned it, so the idea with the questions is that exactly we take them to the lunch break, because there you meet each other and then you can continue discussing about the topics. Yeah, the next one is Lise Chier, and Lise, I directly hand over to you in that direction. So here's your poster, and we are looking forward to your presentation, and also warm applause for Alice.
So, good morning, everybody. I'm Alice, and I'm first-year student, so in PhD student, sorry. So my topic is sensitive device identification through learning of radio frequency fingerprint. And the first word, sensitive, is due to the application context. So maybe you know tempest attack. So an attackant would attack a device, and to attack it, he wants to identify. So the sensitive identification is about this. So to manage this identification, we interest on the radio frequency fingerprint. So the radio frequency fingerprint is a signature, is a unique signature of a radio device, and this signature is due to the due to analog component and the singularity of this analog component. So after 2 months of reading, the state of art helped me to develop some scientific logs. Sorry, and so the first logs is algorithm, because we have many possibilities to identify radio frequency fingerprint. And for example, we can use a parametric algorithm, or we can use the deep learning algorithm. So the state of art is show many possibilities. And the other scientific log is data. Data, because we have many possibilities. For example, we have to choose data. We can do some Fourier transform, or we have to choose the quality or the quantities of data. So data is very important, and some authors propose modelization or experimentation. So we have to choose that. And another point of data is data perturbation, because for example, the channel and the the receiver front end could impact or the radio frequency fingerprint, and we don't want to classify it. We want to classify just radio frequency fingerprint due to the transmitter. So to conclude with my little presentation, this is the general flow of RF fingerprint identification based on the state of art. And so on the first part, we have the device 0 and device 1, because we can have many devices on the environment. Sorry, and every device has his radio frequency fingerprint, and it's unique. And so we have a legitimate receiver, and the objective is with a software-defined radio, intercept the signal and processing it. So, for example, apply a Fourier transform, and next extract the RF fingerprint and do the classification. Thank you.
Thank you very much. So you all have very interesting topics, very good. I'm impressed, and also great presentations so far. All right, so the next one on the list is Alexis Duhamel, and Alexis, also for you a very warm welcome. Yes, you can clap your hands. And,
hello everyone.
And we're eager to hear about your topic.
Thank you.
So my name is Alexis Duhamel. I'm a PhD student since September 2019, and I have been working 1 year as an embedded engineer in industry beforehand. So my subject is about self-reconfiguration of FPGA-based embedded systems. So for those of you who don't know what an FPGA is, FPGAs are field programmable gate arrays. So instead of executing compiled software bit streams, FPGAs use electronical circuits instead. In industry, you usually use big FPGAs matrices to execute complex designs. However, we are able to use smaller matrices instead with a technique called DPR, which stands for Dynamic Partial Reconfiguration. This technique allows systems to benefit from high performances in terms of fast computation. In my work, we focus on the management of those DPR-enabled matrices, which is challenge in itself because you don't execute compiled bitstream, but you make use of electronical circuits. So my topics are mappings and scheduling of task level of application management. More specifically, we try to manage a very high level of what we call a quality of delivery, which is a combination of quality of experience, which is what the user perceives when interacting with the system, and the quality of service, which is another metric used to represent how the system is able to perform the expected behavior. This is typically interesting because when you have an embedded system that is autonomous, it is driven by software called mission management. Mission management is a meta application that sends application requests for the system to execute. Example, a drone that has different applications through its runtime. For instance, a navigation phase, and then maybe a vision phase for trying to recognize some people at sea, for instance. So our work is about management of the systems, and we have designed a two-phase methodological pipeline. So the first step is design time, which allows us to make use of very complex algorithms to find near optimal mappings and scheduling to make use of at runtime. And the second step is, of course, runtime. So after having found some near optimal solutions, the runtime step is able to make use of those solutions, but it is not all, because you can encounter some unexpected situations. And in that case, you have to find other solutions, other mapping to execute the desired applications. And in that case, you have to find your own mappings and schedule, which is an NP-hard problem. So we have some hypotheses to reduce the complexity of those algorithms. I don't know how long do I have anymore?
Well, you still have 2 more minutes.
Okay, fine. Thank you. Another challenge of this type of management is multiple application management. Because when you have 2 applications that are from 2 different nature, such as navigation for a drone and a vision application, you can't objectively compare the 2 applications. So we try to modelize the quality of experience from 2 different applications, 2 different nature, via a common metric called user preference, which allows us to objectively compare 2 applications. And when the user tries to reach what he thinks is the highest maximal quality of delivery, the system autonomously changes mappings and the schedule. So which tasks is being executed on which resource to try to find the best way to execute the application. So we have what we call scenarios, which is what kind of execution mode for which application are we trying to execute. Execution mode, for instance, for video encoding application can be image resolution or frame rate. And of course, when we try to have multiple applications running on the system, you can try to dynamically change some parameters from an application to reduce the complexity of what you are trying to compute on the system. Okay? So at the final sentence to present my work, I'd say that what we are trying to achieve is hardware acceleration at a reduced cost and by trying to achieve some real-time performance, as in a sense that we are trying to reach the execution time deadline, not to drop any service online. Thank you very much.
Thank you very much. Okay, so the next one is Abdelhamid Gara. And also a warm welcome to you from the audience. Very good. And then we are eager to hear about your PhD.
Thanks for giving me this chance. Hello, everyone. I am Abdelhamid Gara. I am a fresh PhD student from the University of Burgundy, Lib Laboratory. I just started my PhD since this last November. Also, I hold an engineer and a master degree from the Higher School of Computer Science, Sidi Bel Abbas, Algeria. My topic is about self-management of security service in the Internet of Things. This subject is around 2 points. The first one, ensuring security services in the Internet of Things. The second one, try to adapt this solution with the autonomic computing in the IoT system. I ask some research question here about what are the main challenges investigated in both topics, IoT security and self-management of IoT security by researcher. What are the open issues in
And to do so, we'll all walk together. I show you where we walk, but we all walk together. And then we'll be back here at 1 o'clock for the keynote of Josephine. So we are here, and we'll walk over here, and it's not as long as it looks like. It's just, as you see here, 12 minutes walking to this nice place here that is called Étoile, so star. And we'll walk over there, we'll have lunch, and then afterwards we'll work back and use the time to chat with each other and enjoy lunch, and then we'll be here again at 1 o'clock. See you at lunch. You have to switch to the one. Okay, perfect. Good. And we have to connect it actually. No, it's correct. It's only we have to put the cable in.
Do you have audio?
All right, then welcome back. Hopefully you enjoyed the coffee. Yeah, actually, yeah, do we want to start with the missing PhD poster? You want to do it? Perfect, because then come down, because Hubert just arrived, and yeah, then I would say let's just give her also the chance to present herself. Let's just open the slide. Perfect. So, yeah, you can just come here. And yeah, so Hubert also arrived. She had quite some difficulties to come over. Therefore, we're even more than happy to welcome you. And yeah, you have about 5 minutes to present the poster. The others did it as well. And as I told you, you can watch it in the stream because it's quite interesting to see what they're doing. Okay. And just come up here.
So, hello everyone. I will be presenting my poster. So I'm Hubert Mary, and I'm a PhD student since November 2020. I'm specialized in artificial intelligence, and I'm a PhD in the University of Rennes 1 and ERISA. My PhD thesis is about e-health smart agents conception in the context of communicating objects. And actually, we aim to develop intelligent services focused on the needs of humanity. And the object is to exploit, actually, the ecosystem of communicating objects with artificial intelligence. Also, we aim to resolve the shortcomings of current systems proposed to assist and monitor dependent people such as elderly and isolated persons. So, my research questions, I have many research questions, especially how can we define actually the context of individuals, which is the context of a smart home. We focus on smart homes in order actually to provide personalized services. So the services we wanted to be related to the profile of the person. So we can say also how can we really distinguish between what we can name as a behavior, a normality, or a normal activity of daily life. So we focus also on supervising daily life activities. We want to predict and detect possible health deteriorations. For example, we can have long-term supervision such as for Alzheimer, depression, and also instant problems like falls and maybe also suicide. How also can we apply artificial intelligence, especially in this context, for decision-making systems? So we have many challenges in this thesis. Actually, is that we lack medical data sets for test purposes. So it's a really important matter. Also, we want to better understand actually the real-world application in healthcare. And the latest challenge is how can we real-time process data for efficient instantaneous decision making. So recently we published in the International Conference of Data Engineering and Automated Learning. So it's related actually most to the intelligence, artificial intelligence, such as neural networks. The article is entitled Hierarchical Multi-Level Classification of Multi-Resident Activity. In this article, actually, we tackle the problem of multi-resident daily life activity in the context of multi-resident smart home. So we want to supervise the interaction between the residents and to detect problems of daily life. And we proposed actually a hierarchical multi-level classification based on neural network, which is provides a reasoning based on real-world scenarios and a hierarchical representation of the smart space. In this article, we have many problems, such as we have many actually many notions that we tackle. So multi-resident recurrent neural networks, long short-term memory, convolution neural network, hierarchical multi-level classification, and activity recognition. If you want to know better about this article, we can speak about it. Okay.
Good. Perfect. Thank you very much. Okay, perfect. So now you really know everybody who's on site, which is very good. And yeah, so then we come back to our regular program, and the next part is the presentation of the challenges. As you know, you will have some time on Thursday and Wednesday to work on the challenges. We have 5 challenges, and we'll now give you an idea what the challenges will be about, and we'll make the assignment of the teams on either tomorrow or Wednesday. Yeah, probably tomorrow afternoon. For the challenge with Josephine now, you will also make teams, and tomorrow with Siemens you will make teams, and for the other challenge you can stay in the same teams of typically 3 to 4 people, or you do different teams. So basically it's up to you how you prefer to do it. Okay, so Laurent has to leave us, so I give this floor directly to him. I just created slides with a number, and yeah, so we're in the challenge presentation, and Laurent is the topic number 1.
Or number 3, I don't know. You put it number 1. Okay. So hello everyone, I'm Laurent Toutin. So I'm sorry, but I have to rush just after because I have to take a job, and I will not want to miss it. And I will come back after if I survive. So we can talk together. So who knows LoRa or LoRaWAN technology? Only 4 people? Okay. So LoRa is a radio technology developed for IoT, and it's very, very well designed for very long-range communication with very limited data to send. And the problem is that you can connect your device with it, but you cannot put IP technology on it because IP is too big compared to the capacity of LoRa networks. So that's why we have developed at IMT Atlantic and with other people a compression technique that is called SCHC, S-C-H-C, static context header compression. And this way we can put IP addresses on these devices. So this is used right now, for example, in metering. So you can have electricity meter that can be connected using their legacy system and send IP packets compressed with SCHC over the LoRa network. So normally the sponsor of this challenge could have been Aclio, so a company that do the standardization and also products around SCHC. But unfortunately this week there is a utility weeks in Italy, and all the staff is there. So I will try to represent them and to propose you a challenge, because as I told you, now we can do electricity meter, but there is other IoT that use IP. And recently, the LoRa Alliance had made an announcement. This is a marketing announcement that says that we can use SCHC to connect backnet network. So BACnet is IoT technology used in building to control air conditioning, lighting, etc., etc. And normally they are based on very, very specific media. And what we would like to do in this challenge is to prove that the marketing is right and that we can use Chic and LoRa to carry BACnet traffic. So to do that, we will use open implementation of Chic that is called OpenChic and written in Python. We have some BACnet trace, and the goal is to say how much we can reduce the traffic using Chic technology to be compatible with the LoRaWAN constraints. So it will be done with Ivan Martinez here, and we will so explain you how to use Chic and maybe how to also to use some tool like pickup to get capture from packet, and then we will have to design Chic rules and Chic behavior to compress the BACnet traffic.
Sorry.
Nicolas continues. It's fine for me. So, true.
Yes. I will talk about two projects here. So from Wednesday, we have another community who will join us, who is called Camp OSV. Don't know if you saw this on the website. There's a little description on it. So it's a community here in Rennes working on the open source vehicle. So it started when we bought open source vehicle, which is an electric vehicle with most of it open source. And the idea, so one was bought by Université Rennes, and one was bought by IMT Atlantic. And since then, it's 5 years ago, something like that. There are camp where they meet and try to develop open source building blocks for this vehicle. And so we continue working on these kind of things. So electric mobility, I could call this. And we have two challenges that we propose this year for the winter school. So one is to work on the powertrain of the vehicle. So the battery management system, which is the system that manages the different cells of the vehicle and make sure that it's well balanced, well charged, and things like this. And the motor controller. And so we'll bring here all these pieces. For some of them, we already have some blocks that are developed, and some other needs to be developed. So that's one project, and the other project that we started with students from IMT Atlantic is to make a cargo scooter from scratch. So they are building the I don't have the word in English. Chassis. The chassis. We say the same in English. The chassis of the scooter, and that should be finished for Wednesday, more or less. And then we'll try to connect the motor controller, and the battery management system all together, and to make this communicate with a smartphone that is next to it. So that's more or less the two projects. Okay? Thanks.
Good. Okay, and then, I don't know, Christian, if you want to come, do you have the hardware? Okay, maybe bring it. So, okay, and then we have two more challenges, and they are actually related to the event here, because we have some interesting IoT devices. So we have these lights that you see there, and also in this video here. So they are audio controlled, and you can also control them via Bluetooth. And they have a microphone within and a microcontroller. And the idea of this challenge, and we also have a clock, a huge clock, that is controlled by infrared, and the idea of this challenge is creating a system that is telling the speaker how much time is remaining of the speaking time, so that you can set a timer, and then it's showing you, I don't know how you want to do it, but it's showing you in a non-intrusive way how much time is left for you. So it could change the color, it should make the bar, could make the bar shorter, etc. The challenge there will be to look at different IoT protocols, find out how to make them interoperable, and how to script it so that we have something that does that. So this is one challenge, and the other challenge is, as you know, we are streaming the videos, and we already have some scripts that are taking automatic screenshots from the stream. And the second challenge is developing a mashup of tools that is transcribing the audio, interpreting the audio, and automatically making Twitter posts or Instagram posts. And this will have to do with AI. And this will be the second challenge that we have regarding the event that we have here. Okay, so these are the 5 challenges, and yeah, we'll let you know some more details tomorrow. Okay. Thanks. Then we are again as punctual as we can be. So it's almost 2 o'clock, and at 2 o'clock I have the pleasure to welcome Josephine Hubert, and she is from Celonis. I also have her slide. So I can. Maybe do you want to say something about the Slido first? You have 2 minutes because we are 2 minutes ahead of time. Good.
Challenge, but of course I will try to do it in 2 minutes. So my name is Erkin. We will do a very short hands-on. It will be the first hands-on. I will steal it from you. We are using a nice tool called Slido, and I will show it to you how we can use it. You can take your mobile phones or your PCs and just type in your browser sli.do. That's it, sli.do. All right? Let's go to that page. Here you enter the code. Our code is FIOT, Future-IoT, F-I-O-T. All right? Okay, let's enter. Now, here you can ask questions. First of all, you can type any question. And then I will keep track of them, and I will forward them to the speaker, and so on. Also, we will use some poll features here. For example, I created one of them already. So one of my colleagues, Lars, you already seen him, warned me that the color of the French flag recently changed by the president. So in this poll, can you find which color that President Macron recently changed? We have 3 options: blue, red, white, purple. Purple is not in the French flag. It's my favorite color, that's why I put it. Okay. Now let's see the results. Okay, so you almost all know except white, blue. Anyway, so this is Slido. You can ask questions. We may create sometimes polls. Don't forget our code is FIOT, web page is sli.do. That's it from my side. Thanks for the opportunity.
Thank you very much. And the questions that Erkin is creating are normally related to the topic, of course. So he's not creating side entertainment while Josephine is talking, for instance. But it's anyways interesting and good to follow it. And for those people being live here and those people being on the Zoom, feel free to put your questions also on the chat. You can even put that I'm in the audience, because then you keep track of your question. I can show the question at the end, and then you can still ask it yourself, and then you can just put it the moment where you have the question. Same for the Zoom. You can just put a Zoom in front of it, and then Erkin will call you and put you on the screen for that. Okay. But now back to Josephine. So Josephine Hubert is the Academic Alliance Manager at Celonis. She is responsible for the Global Education and Research Cooperation Program at Celonis. She graduated from Maastricht University with a Master in Psychology, as well as from Technical University of Munich with a Master in Education. And you might have seen it already. If not, now you have the chance. As with all speakers, I recorded a trailer. And yeah, let's have a look at that one together. And then I hand over to Josephine.
I will first of all introduce the process mining technology, where we take data from underlying IT systems or customer relations management systems, so any system where we collect data, and we will connect them with the Celonis software, where we can first of all reconstruct how processes are run in the real world, in the businesses. Then we can analyze and find bottlenecks in the process. And finally, we want to find improvement potentials in order to make the process more efficient and smarter, more effective, more sustainable.
The good thing is that Josephine also will let us some access to the tools that you will use later, and that means also for the challenges you can make access to the tooling of Celonis, and therefore it's very cool. The same will be also the case with AWS and also with Siemens maybe, and therefore it's even more interesting to listen to it. And yeah, so the floor is yours.
Thank you so much for the invite, and I'm super excited to be here because, as Marc-Oliver said, I came from Germany, from Munich, where the Celonis headquarters are, and this is my first presentation after COVID in live. So I had all of the presentations usually online via Zoom, MS Teams, so I'm super excited to be here in person today. And in this keynote, I want to talk about how we are transforming data into value for businesses, for Celonis customers, partners, for you as academics as well. And I would like to show you the execution management system. So as you just heard, you will get an academic access for this. And I will invite you in a second so you can already get ready, take out your laptops. So you have that all for the challenge part later on. And for myself, I'm Josephine. So as I said, I'm Academic Alliance Manager based out of the Munich office, and I take care of partnerships on a global level. So we are making collaborations with professors, with students all over the world. And I'm also responsible for France, the Benelux. I just talked to the 2 PhD students also from Rennes and Leuven. So I'm also happy to have you here. And basically, we bring Celonis into the academic world. So what you are doing here during this week, connecting academia and industry, is what we are exactly doing as well with our Academic Alliance team. All right, so first of all, I already got a question from DJ Erkin here, like how did Celonis grow so much? And how it started was in 2011. So actually, the 3 founders, you can see them here on the picture as well. They were students at the Technical University of Munich, and at the side they were also doing a project for a student consultancy called Academy Consult, and they wanted to help the client, the Bavarian Broadcasting Company that you can see here. It's not pointing on the very left. So also based in Munich, this company actually wanted to have an improvement of their IT help desk processes. And what the 3 founders did was basically finding the technology from research, the process mining technology, and they implemented this technology in the very first software for enterprises. So the first enterprise software for process mining. This is what they built back then in 2011 for this very first project. And then they implemented it with this customer of the Bavarian Broadcasting Company in Munich. And then also later on landed more and more customers. And like this, they actually created a company while still being at university. So they founded out of the Technical University of Munich and grew rapidly since then. If I introduce to you to Celonis nowadays, in this year, you can see that there have been a lot of different investment rounds. So from 2016 up until Series D during this year, the market value increased a lot. So Celonis got several investment rounds. With the last one in June, the market value grew at $11 billion. So this is what we do not call a unicorn, what you have for startups, but actually a decacorn. So the market value is higher than $10 billion. And Celonis reached the status in this year. So actually from the 3 students back then in 2011, 10 years later, they grew the company with a year-over-year growth over 100% every year. They had more than 2,000 enterprise deployments, so meaning that the technology is used with customers. And also very interesting, what I got asked before is how many employees do we have nowadays? It's more than 2,000 across different offices. So not only in Munich and the headquarters, other headquarters in New York, but also a lot of different offices around Europe. And what we do at Celonis is really looking into processes. So you can more think of the way of we are looking at processes with the lens of a data scientist. So we are taking data and we want to see how the processes are run in businesses and how can we improve them. So the whole technology is based on digital process analysis, improvement and execution. And what Celonis is creating is a whole new software category, the execution management. So how do you actually make processes run better in businesses? And this is what we do in the execution management system, where you will all get access for the academic edition in a second. I mentioned the global expansion already a little bit. So I'm based in Munich. This is where all started, but you also see the other headquarters in New York, some other offices around in the US. There's another hub, for example, in Raleigh in the US, where some of my colleagues are also based. Then in Europe are quite some offices, like the closest to here would be Paris in France. Then we also have an Amsterdam office, London. For the Nordics, there's an office in Stockholm. And a lot of developers are based in Pristina, in Kosovo. And as you see, at this moment, we only have one office, which is in Tokyo, in Japan. But actually, today, they launched the announcement of the newest office, which is going to be in India as well. So you see, Celonis is really branching out to all different parts of the world with this hub in Europe and the US, but also increasingly going on to other continents, like Asia. What I do personally every day, so I'm Academic Alliance Manager, and what we do in the Academic Alliance is what you can see here, actually creating this whole community, academic community, around the execution management system and around the Celonis technology. So we have different pillars, and the very first one is what we're actually doing today, so empower the next generation, talking to you as PhD students and telling you what process mining is about, how you can also use it in your research. So actually also driving innovation through research, what you can see at the very bottom. And then we really want to create this vivid ecosystem. So we already have customers, partners on the industry side, but also on the academic side. This is where our team comes in. We are creating out these partnerships with student organizations, with courses. So if some of you are also teaching, I talked to some PhD students also over lunch. So if you also want to use Celonis in your own courses, you can definitely reach out to me and also use our teaching materials. And really want to create this whole academic community, as you can see in the center of our mission. So as said, if you like what you're seeing today with the demo and also with the practical part later on, I'm happy to also support those of you who are teaching, so the professors, of course, as well as PhD students who are also giving some courses to bachelor or master students. And the Academic Alliance is really crucial to Celonis because what we think is that when you already learn about process mining at the university level, then of course you're better equipped for later on once you enter the job markets or you are working in industry. So what I mentioned before, and you will all get the academic edition, and I see most of you already have the laptops out, that's perfect. So if you enter this link, signup.celonis.com, you will actually get to a sign-up page where you first of all just enter your university email address or the one from your research institute, from your university, so the academic email address. This is the very first step that you do after opening this link. And then you will receive an email to your inbox. If you don't find it right away, you can check your spam folders. This sometimes lands there because it's a system-generated email. And then later on, once you are asked to complete a registration, you can put what applies to you. So student, professor, or researcher. So for all of you, I think could be researcher, or if you're also teaching, professor. And then from there, you will get your access to Celonis Academic Edition. So I'll just give you a moment to enter your registrations. And if there are any hiccups, any questions, let me know if it's not working properly for you. And then you will all get access in a minute. So you have your academic edition for the practical parts later on in this keynote, and then also in the case later. Do we have any people online as well?
Online?
Yeah.
Yeah. On YouTube?
You could post this link maybe?
No, they are seeing.
Okay. That's great.
And would you like to?
Yeah.
That's all right.
Thanks. Okay, so I hope it's working for everyone. If not, please let me know if you're having any problems there. I'll just walk around a bit to see where you are at. Okay, I think all good. Do you want to have the link as well? Okay, thanks. Is it working for you? Perfect. All right. Yeah, you can also do it on the phone, on your phone, of course. But then, if you want to also if you want to participate in the challenge, I would prefer, or like I would recommend the laptop because it's actually better on your laptop or an iPad than on the phone. But you can do the registration definitely as well. Okay. So in case you do not receive the email or anything is unclear, please let me know. I'm here to help in person, so this is really nice. All good? Okay. So I'll just leave you a little bit of more time. The good thing about this academic edition is that you can use it as long as you are enrolled in a university, so as long as you have access to your university email address. So you can use it, of course, for today, for the challenge, also later on if you want to use it for your own PhD or for your teaching. So you won't lose the access at any point in time, as long as you are having access to your academic emails. All right, do you want me to go on, or do some people still need time to register? Yes? No? Okay, if it's still loading, then it's fine. So you can complete the registration then in a little bit, so you're on the good way. Are the others ready? Okay. All right. Then let me show you what I was planning to do today in this keynote. So first of all, we'll have a deep dive into what is actually process mining. And are there some people who have already heard about it in this room? Can you show hands? One person, because we talked earlier? Yeah? Okay, great. Then I will just explain it to everyone from scratch so you understand what the technology is about. I will show you the theoretical foundations because, as said, this technology comes from academia, so it's very interesting for you to see how it actually comes from research and is nowadays applied in the business world. Then in the live demo, I will show you a process in the execution management system. So this will be an ordering process because I think all of you are ordering some stuff online, some articles, products that you need for your own lives or for your research lives. So I will give you the demo about a delivery process. And then in the next part, we will actually apply this. And you will get the chance to also solve a little challenge question just to warm you up for the challenge later on. So this will also be about the order to cash process. And then in the end, I would like to show you where you can certify yourself. So we are having quite some online courses for academics, entirely for free. You get a certificate at the end, and these are really well done from our team, from the Celonis teams. And just recently a new course came out with the so-called godfather of process mining, who is Professor van der Aalst from the University of Aachen in Germany. He started off in the University of Eindhoven in the Netherlands, and we created a course with him together. So I will invite all of you to also take that course and share with you the details at the end. If you have questions, you can use the tool that we learned, or you can always just show hands, so you don't have to wait until the very end. All good? Then let's kick it off. So first of all, speaking of process mining, I want to start with the definition of what is actually a process. And I think it's maybe intuitive for some of you, but still I have this very straightforward definition for you. So we're talking about a process in the sense of having a lot of different activities or process steps that are linked to each other. They appear in a certain order, have a specific sequence that they're following through. And at the end, we have a particular business goal or like an objective we want to reach with our process. And in the visualization, you nicely see that we are following the different activities. For each and every activity, we actually have a timestamp. So that's why we have the little clock here on the right, because we want to see what time does this activity actually happen. So we can also see how long does our process take in total, and how can we also optimize this process based on the times, the throughput times, for example. So asking you now, with this definition, what processes do you encounter every day? What processes do you have in mind? Anyone from the room? Can be a morning routine, so a different process for different activities that you need to take in the morning to come to university, or if you think about your own publications, There's also quite some steps that you need to take in order to publish in the end. So these are different ideas. And what other processes can you think of? Yeah. Yes, very good. So this is your goal would be actually to have your computer turned on, but there's different steps that you need to take. And maybe you are having some difficulties now, so you have some loops that you need to take, like restart again, try to plug in again. So this is a process in itself. Very good. Any other ideas? Yeah? The pancake recipe. A recipe of? Pancake, yeah, very good. So here again, we have the goal of having the pancake at the end, and then you would need to follow different steps in your recipe, so different activities, yeah, very good. Any other idea from your research, maybe? Different processes that come to mind? Yeah?
Yeah, writing a research paper.
Very good. What different steps would you say would take most of the time in this process?
Yeah, good question. Sometimes a literature survey, writing the related work, sometimes doing the experiment, sometimes presenting the experiment results.
Yeah.
Depends on the research, it takes different phases, it takes different times.
Very good. Thank you. So yeah, we see definitely a lot of different activities. Some take longer than others. And in the end, you want to have the publication. So this is your final goal here. Very good. So this is like some examples of processes, and we want to focus a bit more on processes that we have in businesses. So for example, in the automotive value chain, you can see quite some different processes. For the customer side, we have this order to cash process, customer service management. Then in finance and administration, there would be processes like accounting. And on the product and services side, we also have a product development. So maybe some of you are also really familiar with that. So you have different steps of actually developing your product, and then also having this life cycle management of your product. And then on the top left, supply and distribution would also have some different processes. Like here highlighted, we have the warehouse operations or a purchasing process. So whenever your product is actually out for sale, then of course you would also have this purchasing process. Some others are buying your product. So this is only like this wheel of the automotive value chain, but you can also think of other industries. So for example, the software value chain, again, you have a lot of different processes that are coming with it. On the right and left side, you would see the key performance indicators, so actually the numerical values that we are collecting for these processes. So it can be, for example, the app velocity or engagement, satisfaction of the customers or of the partners. So really, only in the software value chain, you already have a lot of different processes and different ways to measure them. Same for banking. So a lot of different processes involved in financial services and insurance, for example. And another example I also brought from telecommunications value chain. Again, you see how diverse this universe of processes can actually be. Speaking now a bit more in depth about what is process mining. So if we have a look at this visualization, you can see, first of all, the source of Professor van der Aalst here on the side. So Wil van der Aalst is his name, and as I said, he started off at the Eindhoven University of Technology in the late 90s, so this discipline is still rather new, and it's in an interdisciplinary approach. So we are looking at processes and the management of processes in businesses through the lens of data scientists. So we'd have data mining, statistics, machine learning, that you are also, most of you familiar with, as I learned from the group, databases, how can we do predictions. So here again, we would also need the machine learning part within. And all of this knowledge from the data science side is then actually applied to processes. So how do we manage the processes? How can we automate some activities in our process? How can we control for the improvements? How do operations actually change? So you can really see that process mining as a technology sits at this intersection of these both disciplines. So data combined with processes. Now, in a nutshell, if you want to see how the technology works at one glance, we start off always with the real-world activities. So here's an example of a production process. Something is produced, this is from the manufacturing industry, and all of these activities in the production process, they are stored somewhere. Where are these stored? in these underlying systems of record. So every activity that is being performed in the process is actually captured in these underlying systems. And in the systems, we can then, like from them, we can then extract data. So we're speaking here of big data, to throw one of the buzzwords. Here you only see a snippet of an event log. So these are the data we extract from the systems. And these data show us information about the activities within our process. And then based on these log data, we would then be able to create this digital twin. So that actually, let me see if I can, yeah. No, you don't want to see it. So the digital twin is here, a screenshot of the Celonis software. There we can reconstruct how the process is actually run based on the data. So connecting the data with Celonis or also uploading the data, as we will do later on in the challenge. You can then really reconstruct the process flow from start till end and all of the deviations that come within the process flow. And from this digital twin, we can then actually draw back conclusions to the real world and then see what is not going well in the process, what can we improve, how can we predict specific parts of the process to occur. And so we have this interaction between the digital twin and the real world activities. So this is it in a nutshell. If we want to dig a bit deeper into the kind of data we are looking at, you are able to see the process data here. So actually an event log captures at the minimum 3 points or 3 parts, let's say 3 pieces of information, so 3 data points. And the first one would be the case ID. So you can think of a unique identifier, unique identification number that you follow throughout the process. And for each and every case ID, we have several activities. So the second column shows the activity names. For example, creating an order, approving the credit check, preparing the shipping. So these are all the activities that are all connected to one specific case ID. And then, as I mentioned beforehand, we also want to know the time. So the date and the timestamp is important here to see when the activity was actually performed. And this is only like a small snapshot. If you ask my colleagues within Celonis who are working with the customer data directly and are helping them in the implementation, they would say that usually you have millions of rows of columns, so different data that are also included here. And speaking of big data, as I said earlier today. As an overview, we can see that everything starts with this event log, but you can enrich the data with master data. So there's another table here at the bottom where you can actually get even more information about your customer, for example, include the price of the different products that are purchased or ordered here. And we have this end-to-one relationship between the event log table and the master data. And both tables together, or several tables, as we can also see, as we will see later in the case challenge, these make our data model. So this is where everything is based upon. The data model, this is where it starts. And then based on this, we actually can create this process model. So in the middle, you can see that we can reconstruct the process, as I said, on the data that we get from our data model. And we can see the different activities, also deviations in our process, and really from end to end, so from start till end of the process. And what we eventually want to do with process mining, and you will also be asked today in the challenge, is how can we actually improve the process? So we first start with the process performance, how is the process run in reality? Are there specific bottlenecks? So these are some parts of the process that are not working well. I will also show you the conformance, where we compare the real data with the model. So we are actually seeing if the cases are conforming to our process model. And then in the last part, we want you to think about how can you actually improve the process. So the enhancement part will be not only investigating based on the data how the process is run, but also thinking of ways how can you improve this process. So we have not only looking at the performance and the conformance, but also the process enhancement at the end. Where Celonis is already implemented, as you can see it here on the slide, is in a lot of different industries. So wherever we have processes and data about these processes, so this is really the requirement for process mining, we need the data, of course. There you can also apply the technology and use the execution management system by Celonis. So varying from manufacturing, where we have one of the first customers, Siemens, over to high tech. There's the example of Uber. If some of you are using Uber, or if you're ordering Ubers from time to time, so we are also helping them in their customer service processes to improve them. Over to telecommunications, the energy sector. You can also see the consumer and retail. So here there's some logos like the Coca-Cola company or Heineken that are also using the technology in order to look into their processes and improve them. Over to pharma, chemicals, finance, as we also saw earlier, so different financial processes with ING, APG, ABN AMRO, or UniCredit here as an example. And one other example I really like to mention is the Lufthansa example in the airline and aerospace sector, because Lufthansa CityLine is using process mining for their grounding and maintenance operations. So whenever the airplane is waiting in the airport to take off, there's so many activities, so many process steps that need to be taken. Fueling, repairing some parts of the machine, boarding the passengers. So this is quite complex that you actually, all of this need to take into consideration. And the data help here to get the overview and see where things are not working well, are not running in the right way. And here in this initiative with Lufthansa, they actually found out a lot of different results. One I want to mention here is in the boarding process of passengers, they just implemented rotating shuttle buses because they identified in the process that usually there's a queue for passengers to take, so they have to wait for a long time to board the plane. And with these rotations of buses, they could have first half of the passengers in the first bus, they already board, go into the plane, and then the second half would be coming afterwards. And then this is something quite intuitive if I tell it to you, but they actually found it out based on the data, and they saw that there were long throughput times in the boarding process. So this is a result that came out of their process mining initiative and now helps them to leave on time, have punctuality of flights, and also higher satisfaction of the passengers because they arrive on time at their destination. So again, from this slide, you can really see that the process mining technology works wherever we have data around processes, and maybe this also helps you a little bit to think about where you could also see it yourself. So is there any touch point in your research or also in your teaching where you are encountering processes and where you have data around your processes? I also brought some other examples from L'Oreal. I'll just skip over it. I brought two from the customers, one based in France, the other one from Germany. So L'Oreal actually used process mining in order to win its war on blocked orders. So they wanted to reduce the blocked orders. You can see here the results are 25% reductions, and wanted to increase touchless orders. So actually increase manual work and automate more parts in their process. And in the end, they could increase their productivity by 20% by using the process mining technology, showing them where to automate specific parts in the process, and this way making the process more efficient. One example from L'Oreal, the other one from Germany, as we're speaking here to a French-German audience or academy. Zalando is based in Berlin, so these are a retail, fashion retail company. They started off with orders online, so actually now they also have more and more physical stores as far as I know, but they started really off with these ordering processes. And here in an order process, you would normally have a specific way to take throughout the process, so you need to check for compliance, so meaning that whenever you order something, this has to be confirmed, and normally the purchasing department would confirm your order. However, if this is not the case, if this is not done like that, we are speaking of maverick buying. And maverick buying actually means that without confirmation, a specific purchase is made, and this is not compliant to the guidelines of this process. So what Zalando did with process mining was reducing the rate of maverick buying in their process, so actually being more compliant. By 75%, they were able to reduce maverick buying. They could also, in the end, have more electronic invoicing over 2 years. So you see 50% is the rate for that KPI. And in the end, they had twice as much purchasing catalog utilization through a functionality from Celonis called Action Engine, where you have more and more automated parts also within the process. And they also use quite some machine learning. So that is, I think, also interesting for some of you developing own algorithms and working with machine learning techniques. So these 2 examples, before I want to go over to the practical part, showing you the Celonis execution management system live in this demo. And before we go into the software, I would like to pinpoint to you some of the functionalities within the Celonis execution management platform. So where everything starts is with this layer at the bottom. So these are all of the different systems that can be supported, and we are extracting data from there. So for example, an SAP system or a Salesforce system, or even desktop applications like Office, Excel, and so on. And from there, we take all of the data. So these are the underlying data that we need for our process mining initiative, for the process mining technology. And then in the platform, you see different parts that are very interesting and rooted in our product. So there's first of all the real-time data ingestion, then process and task mining. So task mining specifically looks at not only the whole process, but also desktop applications, as I mentioned, that users are facing every day and are using. So here task mining focuses on that. We have planning and simulation. So simulation is also getting more and more important. Visual and daily management, and finally also action flows. So this is the part where we're thinking more in terms of automation. How can parts of the process be automated? So this is very theoretical, and I would like to show it to you in the demo now. So going over again to the academic edition, you can open your own accounts now. And can you still hear me like this? Yeah. So you actually can follow me throughout the demo, look a little bit through the different functionalities together with me. So later on in the challenge, you will all be ready to also solve the challenge yourself. And I will change into my academic account as well. If it's showing. No. Okay. Here we go. So once you open your academic accounts, you will see the same that I'm showing here. So we have different functionalities. You see all of the functionalities on the top bar. So we will focus today on the business views. This is where you can see different processes. And there are quite some demo processes already in the academic edition for you ready to use. Then in the studio, this will be the part where you'll be working later on. So this is where you can edit your own analyses, create own analyses based on the data that you uploaded. And then in the event collection, this will be interesting for your own projects. If you want to analyze own processes, you can simply upload the data there. In the event collection, there's a file upload that actually shows you, I can show that as well here. So in the event collection, you will be able to see, if we're just opening one of the examples, here there's this file upload where we'll all later upload the files for the process that I prepared for the challenge. And you can also do that with your own files. So if you have Excel, CSV files, JSON, these are all supported. So you can upload them there and work on your own processes from this. And also quite interesting for those of you working with machine learning. So we also have the machine learning functionality. There is a full Jupyter notebook integrated. So for those of you who are working with Python, you can also make use of the machine learning functionality within Celonis. And this is especially interesting for predictive processes or like predictive analysis if you want to think about how your process is going to evolve in the future. So based on historical data, you are then able to do that in the machine learning tab. For this demo, I would like to show you the process of the order to cash. So if you follow me into the business views, and then in the order to cash, this is here number 5. We can open the version in euros. What we can see here, first of all, is how many cases are we following through the process. So we are, in this order to cash process, talking about sales order items. So these are actually all of the items, all of the cases whenever something is ordered. We create the sales order item, and here in total we have 988,000. And this corresponds to a net order value of 1.25 billion euros. So if we want to have a look at how this process actually is looking like, then we can have a look here into the Variant Explorer. So we see all of the different activities from process start till process end. First of all, it starts with receiving the order, and this has to be confirmed. After the confirmation, there is a delivery document that is generated in the system. And this is important because it captures all of the details about your order. So think of yourself, if you're ordering something online from Amazon, for example, then this is all running in the background that you as a customer maybe don't see with all of the different activities in the front end. Yeah.
Maybe I benefit from having a microphone. So who creates this? Is this a customer who creates it and then the customer feeds it with data? Is it your software that automatically creates it?
Yeah.
Where do the steps come from?
So who creates this specific visualization of the process is mostly teams within Celonis together with the customer. So they're actually thinking of, so for example, which KPIs do we want to show in the dashboard? So if they say we also want to include customer satisfaction here, then this KPI would also be created within the dashboard. But where it all starts is really what I was explaining before. It starts with the data. So the customer, he or she, the customer actually gives the data that are collected in their system. So in this example, it's from an SAP system. And then once these data are prepared, so in the event logs as we saw them beforehand, then they can be connected to Celonis or uploaded into Celonis. And then from there, you start creating the dashboards based on the data model. So this is created by Celonis teams that are working closely with the customer, but the customer usually says, these are the KPIs that we are tracking, these are the KPIs we want to focus on for our business. So this is very important to have these prerequisites and working side by side with the customer in the beginning. Okay,
that was very helpful. And so now there's in every item, there's the same number of data sets. And how does, so when I'm coming now bottom up, in the sense of I have a raw data set and whatever, a CSV table with certain columns, and how do I have to imagine this now? So for generate delivery document, this is like a filter. There it means that the value here is A and here it's Z or something like that, or how is the data matching now with each of these process step entries?
So we will do that in the case challenge actually.
Okay,
so you have the data table and you have to identify this is our activity table, and based on this we are creating these activities here. So you would say this column is my case ID column where we're tracking all of the numbers, and the other column would be all of the activities. So you're actually having the names that are appearing here now. And then also with the timestamp, we can then also have a look at the throughput times. So now I'm showing here the case frequency, but if you change this little icon here on top, you can also go into throughput time on average. And what you're seeing now on this process flow, if we take it in days, is actually how many days are between these activities. And this is of course also really relevant to see the overall throughput time for that specific variant that we are showing here now. So to answer the question, we will actually prepare this later on also in the challenge. So you then, based on the data, can directly see the process flow here in the Celonis.
And the reason why I ask is also when I went with you through the training, for me this was very abstract. because I'm not at all into these process diagrams and visualizing the data like that. And for me, therefore, it was a little bit magic, this transition between the data and this here. And this is why I also asked the question. So if you can be more explicit later on that when you explain it, I think it would be helpful.
Yeah, for
and
sure.
For the participants, you can just ask these kinds of questions, because in the end, Josephine is doing it exactly for you. And therefore, whenever you think, okay, I'm stuck here, just ask her, because she has much more wisdom than she's normally telling, because it's a typically expert problem that you think everything is clear, and therefore really use the opportunity to ask. We're a small group, and therefore it can be super interactive, and I think she's happy about it.
Definitely, thank you. Did you have a question?
So I wanted to ask this. I mean, this looks quite fascinating. I mean, you are taking an X-ray of a company, of its processes. I was shocked, like you show some of your customers, they are giant companies worldwide, like all Fortune 500.
Yeah.
How they are willing to hand you over all these, some of them it might be even critical data. Don't they sometimes even say that, yeah, we don't hand over you the data, you give us the tool, we will do it on our own, we will end up the results. It's interesting, like how did you convince these?
Yeah, very good question. Like I see two questions in this. Like first of all, why are customers using the tool? In this, yeah, exactly. Because so what you can see here, it's showing this X-ray of your process, which normally you would know, like based on like different departments that are working on the process, they have an idea how the process looks like. But here we really want to have a look at it objectively based on the data. So this is the first eye-opening experience for the Fortune 500 companies that are having the license of Celonis and are using Celonis for their own processes. What you asked now, like why would they give out the data? So otherwise it wouldn't work. If they only have the tool, I mean, we can see it also later on. I gave you the tool now, but if you are starting to work on Celonis, you need some like expertise, like to get familiar with it. Maybe it's easier for you as PhD students, but people working on the processes directly, they don't have an IT background, so it's very hard for them to get started just by their own. So normally they're actually already in the pre-sale cycle with my colleagues from Celonis. They are already giving out a sample data set. So this is what we call a proof of value. And with this only like the first data set, so this tryout data set, let's say, they already build out dashboards and show the business value to the customer. And once they are convinced, after this pre-sale cycle, then they sign the license and they actually start with their whole process mining initiative. So first of all, in this proof of value, data is needed, so the customer has to give it in order for them to see the value in the end. And the other question that I also heard about privacy, so what can we do about that? Of course, these data will be pseudonymized, so there won't be saying like Marc-Oliver is doing this activity or Eric is doing this and this activity on a regular basis, but you would actually get pseudonymized, anonymized numbers. So in this sense, especially in Europe, in the US, it's a bit of a different story. Data privacy is a huge issue, and these are randomized in the sense that you cannot trace it back to specific employees of the company.
So my remark is that, I mean, there must be quite a trust between Celonis and the companies, because like some of them don't even share anything else outside their revenues or number of employers. It's I found it interesting to hand it over.
Yeah, I mean, it's trust on the one hand, and also in the end for them to really generate this business value, because they're paying quite a bit to get the license, and of course they want to have a return of investment. So when they see that with this process, the order to cash, I didn't even show you some inefficiencies here. So for example, if you drag more and more variants here, you can also see that there's this extension of a confirmed delivery date. And that actually means that the process will take longer. So you see, instead of 3 days, we have now 5 + 5, 10 extra days. So the process slows down. And if you actually see this with Celonis in your data, then you can act upon it. So the idea is for the company to really get out the return of investment. They pay for the license, but they also want to get the results and see how they can improve their process. And for this extension of the confirmed delivery date, which would mean that you as a customer, you receive your order at a later point in time, there are also some intelligent actions that Celonis suggests. So with the actually the action engine part that we see up here, or also the action flows, you can then create scenarios that are saying, like, for our top customers, if they have a late order, we will actually give them a warning and tell them right away that your order will be not on time. So they are kind of satisfied, they wait, they know that they have to wait for a bit longer, and maybe they also get a reduction on their next purchase because the process took longer for them. And so these intelligent actions, so sending out notifications whenever you see that the process is deviating from the ideal process, this is something that is very valuable to directly act upon these inefficiencies in the process. And I showed you one example here of the extension of the confirmed delivery date. You can also have an exploration of more and more variants. So here, another variant of our process would show, if we use this animation, that after shipping the goods, these are actually returned, the order is cancelled, and then the process ends. So you're thinking of yourself, whenever you order something and you send it back, what does it mean to the company where you're buying from? Any ideas? You're ordering something online, you didn't like the product, you send it back and you cancel your order. So what does it mean for the company? Exactly, they don't make any profit with you as a customer because you're sending back the product, you're not paying for it. We don't have the part of clearing the invoice at the end. So they're actually losing money. And this is a very big inefficiency that we can see here with these returning of goods and canceling the order. So what you can do in this dashboard is actually focus on all of the cases where we have cancellation of orders. So here in 8% of the cases, you can pick with and keep the selection. And then here on top, we have a filter of all of our cases that are going through cancellation of your order. And then you would see directly what does it actually mean in terms of numbers of cases. So here, 8% was already calculated for us. And the net order value that the company could potentially lose, as you said correctly, is also stated here. So 74 million euros. So here, this is also what you asked about, like, why would companies do that? They can save money if they see, okay, they have this problem here with cancellation of orders, and think of ways how to improve it in order to actually keep this cash flow for themselves. So in the end, it's really maximizing their business and also improving the customer satisfaction in this example. Then we can also have some other insights. For example, if you go to the next sheet, here at the bottom, you have different sheets that are already there for you. And in the overview sheet, we also see here the development over time. So you can see that there are the specific months. Some have a higher amount of sales order items. Some others have a lower net value. For example, in this month here, we have less orders and less value that the company would actually receive. And interesting is also to see where the problems are based on the customer. So we now have this filter on cancellation of orders. And if I want to see which customer actually has most of the orders with a cancellation, then you can filter here in descending order. I hope you can see it, or is it very small for you who is sitting at the top? You can click into this field of orders and then see that the Queen Industries has more than 3,900 orders that are actually cancelled. So in this case, the company wouldn't make any profit with them. So you could also filter on the Queen Industry, set a filter here, and then see how is the process running for them. So how are the different activities going forward for this Queen Industry? What is the development over time? So you see where are actually most of the orders for this customer and where are less of them. So in this sense, you can really discover the process based on these interactive dashboards. So this might be very boring for you, and that's why in the case challenge, we will actually focus on how can you create your own dashboards for a delivery process. So this will be more the hands-on part, where you connect the data to Celonis and then also create a dashboard from scratch. So we will do that upstairs in the group rooms, where we then also upload own data and then actually create these dashboards here. One example I would also like to show before we finish off is the so-called conformance check, because this will also be part of the challenge later. So if you open this conformance sheet, this is where you can see how many cases are actually in line with our ideal process flow. And it says here that automatically Celonis calculates this for us in the background based on conformance algorithms. So 59% of cases are conforming to the model. If you ask me now, but which model are you talking about? Then we can see it here in view process model. And this is actually the model very similar to this first variant that we had a look at in the beginning. So it starts off with the order is received, and it takes here the different routes until the goods can be shipped. Later on, we have here sending the invoice, and once the customer paid, clearing the invoice, and then our process ends. So it really shows you the process flow from start till end, and this is the ideal process. So like this, it can happen, but whenever there's an activity that is not in your ideal model, then Celonis would tell you, like, there's a problem, have a closer look. And this is what we can see in the list of violations. So here are actually 40 different violations. And the first one is in 17% of cases, we have this extension of the confirmed delivery date. So these are the cases where our order is already confirmed, but then the date is actually pushed back, so the process takes longer. And this is very inefficient and also not desired in our process. So here we have actually this specific activity flagged as an undesired activity because it takes extra time, aggregated 29 days, and it also is an extra step in our process. And other violations would be what we also talked about, cancellation of the order, returning the goods. These are all listed here. So if companies want to have a quick glimpse into what is not working well in our process, what is not conforming to our model, they could quickly check in the conformance checker where are actually the violations to the ideal model. And then here you see in how many % of cases these are occurring, and what does it also mean to the process. So this is kind of this bottom-up, top-down approach. There you can start, see the violations, and then think of ways how to improve the process based on here. Do you have any questions about the demo?
There's a question, general question. So it's anonymous question to Slido. It says, what is the main difference between Celonis, UiPath, Software Aktiengesellschaft? Probably these are competitors. Why or Software AG?
Software AG, I'm not familiar with, but UiPath is actually focusing on robotic process automation, the RPA integration there. And Celonis has the larger look at the discovery of processes and also finding out these inefficiencies as we were doing here in the demo, and then also thinking of ways how can we automate some parts of the process. So this part of RPA comes in the next step of Celonis, where we have the integration with Integromat, which is a tool that I can also share the link with you later on. So there you can actually automate parts of your process in specific scenarios. And UiPath then is focused on this RPA part, but the idea is what we always convey within Celonis execution management system is first you have to understand your processes, see what is going wrong in the process, what is working well in the process before you can automate parts of the process. Because you start automating right away, maybe you're automating this extension of confirmed delivery dates, which is not a desired activity in our process. So you are actually in the end automating parts of the process that you do not want to have. So these are not conforming your model. So before you start with the RPA integrations, first of all, do a general check of process mining conformance in order to see how the processes are run. So I hope this answers the question. That Celonis is actually also integrating RPA more and more within Integromat that was acquired last year. But process mining is still an essential part before starting with the automations. All right, then I would like to go back to the presentation. And as I promised beforehand, I would like to show to you where you can also get more knowledge about after the session today. So you in your PhD, but also maybe for the students that you are teaching, bachelor or master students, you can also always refer them to our certification opportunities, because these are actually for all academics on a free basis. And especially for you, I would recommend to start off with the Process Mining Fundamentals course. So you can take this link here. It's a bit long, so later on, once you get the slides, you can also take it from there. And actually get access to all of the different courses that we have. So this Celonis Academy, this is the training platform where you have a lot of different courses, such as the Process Mining Fundamentals or the Process Mining Experts, but also other courses based on machine learning within Celonis or based on action flows, so more of the automation part within Celonis. And these are small snippets that you can also take, and most of them come with a certificate at the end. So here for the Process Mining Fundamentals course, you get this fundamentals certificate. There are theoretical modules and also practical case at the end, around 20 hours. And once you've completed all of these parts, you will get your process mining certificate for free. You don't have to pay for downloading of the certificate. You get a badge throughout the training platform, because I also was just asked from PhD students yesterday. And for the process mining experts, it's a bit more of an advanced course. So this is especially if you want to work in groups. And there are intakes every couple of months. And then you're working more intensively for 4 weeks in groups, also on a challenge. And in the end, you get the expert certificate. So these are formats that we are offering to courses. So if you're also teaching, keep those in mind. Now for you, actually coming also more from the theoretical side and from the academic side, I would really recommend the newest course that we have with Professor van der Aalst. It was launched mid-November, so it's very new still. And this course is with him as an instructor. So there was this Coursera course with Will van der Aalst before, but it's really outdated. So here you have all of the newest parts coming from the theory with an introduction, explaining the process discovery, going more in depth about the conformance checking, and also explaining the whole theory behind it with the conformance algorithms and so on. Getting the data, so here speaking about event logs that I also showed to you today, and actually also focusing more on object-centric process mining. This is also something that, especially in his research, is getting more and more important, and also in the whole community. Then the last part, or the two last parts are then comparative and predictive process mining. So here machine learning for the predictions is coming into place. And finally, which is also fitting nicely to the question that we had earlier today, why is process mining also connected to RPA? So here, this is an outlook part in the end. So as I mentioned, once we know our processes, how can we then also automate them in a good way? And this course is very hands-on, so you have lecture parts, also exercises, and yeah, really coming from this academic angle, combined with the industry side, so also having the cases on the exercises within Celonis directly. It takes about 8 hours, so it's a bit shorter than the other formats. And again, if you go on that link here, celonis.com, Will's process mining class, you can register directly to the course, and then from there also get your certificate once you completed all of it. And I would really recommend it to you because it's a high class production as well, and really the newest course that is there for academics and also for industry players. So it's actually for both. Any questions about this course? Anything in the chat?
Yes, so not related to the course, but since you asked, so there is a question, I think this is a follow-up question to the previous one. In the general sense that what if the customer doesn't have big data? Like mid-sized companies, small-sized companies, can they also benefit from you in cases the client doesn't have a huge data?
Yeah, so if they don't have any data at all, it's hard. If they have a small amount of data, then we also have a Celonis free plan. So this is actually a version, an edition of the software, which is for small and middle-sized enterprises, so they can upload their data, as we were also doing in the academic edition today, and then also drive first analyses. So they don't have to buy the license as companies with big data and with a huge amount of data sets would do it. So we are offering this free plan for the SMEs and also for startups. But if there are no data at all, like how would you do the process mining technology? You always need to have the data in order to then really analyze your process. For very like family-run businesses like the pizzeria that we are also focusing on later on, there you can think of actually manually collecting the data. So whenever an order is made, write down all of the activities and the times for it, and then you can still create dashboards. But of course, with the Fortune 500 companies, this is not the case. There we always reconstruct the process based on the data from huge systems. So yeah, the answer here is have data. We want to really push digital transformation. And if you only have a small amount of data, and for SMEs who are not there to buy the license, then use the free plan of Celonis.
Do you also ask for data? Like, you don't bring this, but it would be great if you can bring this kind of measurements and such. Like, do you also ask for specific data?
To the companies?
You realize that it could be...
Yeah, it depends really on the process that they want to analyze. So if they want to analyze their order-to-cash process, then you would need to collect the data for the specific process. Yeah. If they look into, for example, an IT service help desk, as we saw it in the very first project that Celonis was run, then they would need to extract the data from the IT system. So you always need the data, of course, for the process you want to analyze. All right, so finishing off, if there's any more, actually skipped one slide. If some of you did one of the courses, so the process mining fundamentals, or also the course with Professor van der Aalst, you can actually apply to become a Celonis ambassador. So this is something also interesting for you because you're coming from different universities. And if you also want to talk more about process mining, how you can integrate this in your research on your own campus in your university, then keep this in mind. We have the ambassador program for those who have a bit more knowledge about process mining already acquired throughout the courses. And then here are some benefits if you are ambassador that you can also get from Celonis. So this is especially for academics who want to foster more a process mining or machine learning community related to process mining in their campus. So I also put that on the slide, and you can take more information on this link as well. And I think there was one more question that I skipped beforehand in the last row. Did you have one more question?
No, actually you answered.
Okay, that's great. All right. So if there's anything before we go over to the challenge part, feel free to let me know. You also get my contact details here. And as I mentioned earlier, because in the Academic Alliance, we are not only presenting and delivering the case studies with student groups, like we are in the setting today, but we also support for teaching. Definitely reach out. So if this is something interesting for your own universities, I'm happy to get in touch and also direct you to the case studies that we offer, where you can use data in order to actually analyze them within Celonis in your courses. So this is something I also put here. If you are teaching, if you need some teaching support, definitely reach out to me. Thank you so much. And if there are any more questions later on, I mean, I will still be around. We will do the challenge right now. Then don't hesitate. So this is the nice thing to be here in person. You don't have to write anything in the chat. You can ask me right away. Thank you so much for your attention.
Perfect. Thank you very much. So Josephine is here until tomorrow morning, so we will not be here tomorrow, and that means really think if you still have questions, the optimal point to ask them today. So for the hands-on, we'll not stay here, but we'll go one floor up, and this is what we'll do now. So now it's short after 3, and I just take the agenda. So tonight we'll go to the dinner. So you will take how much time for the challenge? 2 hours?
Yeah.
Okay.
So
that means we are also upstairs. So we will then gather together for the dinner. Does any one of you want to go to the hotel before we go to the dinner? If so, please raise your hand just for info that I know. Because if not, we have a little bit more flexibility. If you would want to leave your laptop here, we would lock it even with tonight again. So if you walk through the city tonight and don't need your laptop, for instance, also possible. Okay, good. Then take the stuff you would need for the hands-on upstairs. We are still here, so you can also leave everything you don't need here. Besides that, take your computer, and then we'll meet upstairs in the halls. I think, Nicolas, the stairs are on that side, right? Yeah, so you go outside, to the left, to the left. Ah, yeah, it's the same room like you took for the coffee. Okay, great, and see you upstairs in a minute.